Hi everyone, welcome to our video on how do we find the surface area of a pyramid. This is the fourth and final lesson of chapter 8. If you would like to pause the video to try the do now, now would be the time to do so. All right, the do now states, explain how you would find the surface area of the net to the right. Now you have to look closely at this worksheet because just by looking at this quickly, I may say there are no dimensions of this net, but if you look closely, there are little boxes. This net is laying on a grid or a coordinate plane, if you will. So I'm going to label some of the dimensions here. This net has a square. I know it's a square because it is 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. It is a square, so I'm going to label 6 all the way around. And time to figure out the height of each of my triangles. Remember, we can't count diagonal length in the coordinate plane, so I'm going to count the height. 1, 2, 3, 4, 5, 6, 7, and an eighth one squeaks in there. Just got to look very closely at this. There's a height of 8. This is a triangle. I'm going to make a nice right angle box there. Each of these heights is indeed 8. I'm going to label it for each of the 4 triangles that we have here. And we have 4 right angles also. Okay, so to find the surface area of the net to the right here, how we would do it, you would add the areas of the 4 triangles and the 1 square. Now I know I may have jumped ahead here in labeling the dimensions of this net, but the Let's Investigate asks you to find the surface area of this figure in the do now, so I need those dimensions. If you just gave an explanation here, that's great and correct. So to investigate, find the surface area of the figure in the do now, I explained those dimensions already. So to find a surface area, we need to find each of the areas of the different faces. There are 5 total here. I'm going to start with the area of the square. We know the area of a square is side squared. And we already identified that the length of one of the sides of my square here is 6. I know what 6 squared is. I don't need to use the calculator. It's 36. 6 times 6. So we have 36 units squared. Once again, I'm using units because we don't have a specific length here. These are boxes in a coordinate grid, so we call those units for each of the 1 boxes. Okay, wonderful. The surface area of this figure is going to be determined by now figuring out the area of those 4 triangles, which all happen to be the same dimensions. So I'm really only going to have to do this one time. Triangle 1, I'll label triangle 2, triangle 3, and triangle 4. But I'm only going to really do the calculation once. 1/2 base times height. I'll pick one of them. Let's just say I pick this one. I'll label it 1. Remember, if you circle that right angle, you know that the 2 lengths that make up that right angle must be the 2 dimensions we use in the area of a triangle formula, which are a base of 6 and a height of 8. 1/2 times 6 times 8. And I get an area of, I'm going to use some mental math, half of 6 is 3, times 8 is 24 square units. And this triangle is going to be the same, and same. Each of these triangles are the exact same dimensions. Now, just keep in mind, this net is like almost on a little bit of an angle. So just looking at these different triangles, they don't look to be exactly the same, but it's the dimensions we care about. Each of them has a base of 6 and a height of 8. So they each have an area of 24 square units. So the surface area of this net, of this figure, is going to be my total, which is 36 plus 24 plus 24 plus 24 plus 24, which is a total of 36 plus 24 plus 24 plus 24 plus 24, 132 square units. Wonderful. So our notes for this lesson, we're going to be finding the surface area of pyramids, and there are going to be two different types of pyramids that we're going to find the surface area of: square pyramids and triangular pyramids. Here I have two diagrams of what these nets look like. In the Do Now, we did a square pyramid. The reason why we call it a square pyramid is because the base shape is a square. So the base of this prism, this pyramid, is a square, so we call it a square pyramid. And the other type of pyramid we're going to look at are triangular pyramids. The base, or what this shape is sitting on, the base shape here is a triangle, so we call this a triangular prism. And the net of this looks like a triangle. Look at the colors corresponding. And those other sides that come to a point unwrapped to make three triangles. This diagram showing that unwrapping or that unfolding happening to make that nice flat net. So two types of pyramids: square pyramid with 5 faces and a triangular pyramid with 4 faces. We're now going to try together finding the surface area of two different pyramids. We're going to start with a square pyramid. So square pyramids have 1, 2, 3, 4, 5 faces. I'm going to first find the area of my square base. We know the area of a square equals side squared. And the side of this square base is 7. 7 squared is 49, and our units are meters, square units. Now I'm going to find the area of only one of my triangular faces, because each of the triangular faces of a pyramid are going to be exactly the same. So I'm only going to find one, and then the rest are going to be the same. So these ones are going to go a lot quicker than perhaps the triangular prisms did in the last lesson. So my triangle, once again, I'm going to make sure I circle that right angle, because the two dimensions that make that right angle, here and here, are going to be the dimensions I use as my base and height. So 1/2, that base is 7 meters, because this is a square and all sides of a square are the same. Base of 7 and a height of 10. 1/2 times 7 times 10 makes 35 meters squared. And as I said before, each of these triangular faces are the same exact face, so the area is going to be exactly the same. Same area, which is 35 square meters. Same area, which is 35 square meters. And the same area, which is 35 square meters. Nice and quick. So my surface area is going to be the total here, 49 plus 35, 4 times. You're just making sure you enter this into your calculator carefully. 49 plus 35 plus 35 plus 35 plus 35. It's 189 square meters. If you're looking to save yourself some time, just as a little bit of a trick, if you want to do 49 plus 4 times 35, because it's happening 4 times, you'll get that same answer in your calculator. Very nice. Time to try a triangular pyramid together. So we're going to start with our triangular base. We always like to start by finding the area of our base shape first. And this is a triangle. We know our formula for area of a triangle is 1/2 base times height. We always write that formula first. This is where it can get a little bit messy in here because now there are 2 right angles. So be super careful with what you're doing at the correct moment in time. So we're talking about the base triangle right now. So I'm going to circle the right angle that makes that exists on that base triangle. And the 2 dimensions that make that right angle are 6 and this dimension here, which the arrow is pointing to, 5.2. So 1/2 times 6 times 5.2 is 15.6 square feet. Okay, now it's time for my side triangular faces. There's one less of them because there are only 4 faces to a triangular pyramid, and each of these are going to be the same. These are all triangular faces. This time I'm going to focus on my side face, which has a right angle located here. And we can go ahead and assume, I know we don't like to assume, but I'm telling you now, this triangular base is an equilateral triangle. So each side of this base triangle has a length of 6. So when I'm identifying where my right angle is, the 2 sides that make, the 2 lengths that make this right angle are 6 and the height of 8. 1/2 times 6 times 8. And when I complete that, I'm going to use mental math. 1/2 of 6 is 3 times 8 is 24 square feet. Like in the last question, triangle 2 is the same, 24 square feet. And triangle 3 is the same, 24 square feet again. And to find the total surface area of this pyramid, we're going to add up our 4 area faces, which is 15.6 plus 24 plus 24 plus 24, which gives us, using my trick from earlier, 15.6 plus 3 times 24. Oops, forgot my parenthesis. I get a total surface area of 87.6 square feet. Very, very nice. If you would like to pause the video to give the Now You Try questions a chance on your own, I would suggest doing so. Try them on your own, reference the questions we did together, and then resume the video in order to check your answers. Here we go on the Now You Try. I'm going to find the area of my square base first. This is a square pyramid. Formula for area of a square is side squared. That side length of the square is 2 feet. 2 squared, 2 times 2 is 4 square feet. Now it's time for us to do each of our 4 triangular faces. I'm going to label them. Triangle 1, 2, 3, and 4. Formula for area of a triangle is 1/2 base times height. A square has all 4 same side lengths, so this is 2 also. Circling my right angle and the 2 dimensions that make that T, or that make that right angle, are 2 and 3. Those are the dimensions we're going to use in my triangle area formula. Base of 2, height of 3. Half of 2 is 1, times 3 is 3 square feet. As you know, each of these 3 triangles is going to have the same area. So we have 3 feet, 3 square feet, 3 square feet, and 3 square feet. So my surface area is going to be 4 plus 3 plus 3 plus 3 plus 3. Do some mental math here. 4 and 3 make 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 square feet is my surface area of this pyramid. And our last Now You Try question, our triangular pyramid. We're going to find the area of the triangular base first, which is 1/2 base times height. The base triangle here has a base of 2 and a height of 1.7. 1/2 times 2 times 1.7 is 1.7 square centimeters. Now time for our 3 triangular faces. Area equals 1/2 base times height. 1/2, the 2 dimensions for my faces, circling my right angle. This base triangle is an equilateral triangle, so this is also 2 centimeters. 1/2 times 2 times 3. The 2 amounts that make that T that form our right angle. Half of 2 is 1, times 3 is 3 square centimeters. As we know, these are the same, so they also have an area of 3 square centimeters, which makes my total surface area of this triangular pyramid 1.7 plus 3 plus 3 plus 3 more. Using my calculator, plus 3 plus 3 plus 3, I get 10.7 square centimeters. Very nice job. To summarize, which figure does not belong with the other 3? Explain why. Checking out these 4 three-dimensional figures, I am noticing that 3 of them seem to come to a nice little point at the very top. So that leads me to believe that this figure, the triangular prism, does not belong, because all the other shapes are pyramids. One of the reasons why we know that is because the faces are triangles. Not all the faces, because this base appears to be a square, this one's a triangle, and this one is a 1, 2, 3, 4, 5, a pentagon. This is called a pentagonal pyramid. But those side faces are all triangles. All pyramids will have faces that aren't the base, triangularly shaped. All right, everybody. Hope you understood the lesson. And as always, if you have any questions, please feel free to reach out to any of your teachers via Remind, the Google Classroom, or just shoot us an email. We will be happy to help you. Please watch this video carefully and reference it as you are completing your quizzes, homework assignments, and those CASEL learnings. Have a great day and talk to you soon. Bye.